Hello, everyone. Welcome to another podcast broadcast of This Week in Science. We are ready to get going. Blair's running a little bit late. Will be joining us as soon as she's able to, but we're going to get this show on the road because Justin has to go to work and have meetings, do that thing that happens in the morning in other places than where I am right now. Yes. Who's making hot dogs? Discord? What? All right, everybody. If everything sounds good, check. We will get started. Yes, nerds. Yes, R and lore. Maybe they'll do a remake of that one next. Everything. I think Animal House would probably be like the most un-PC, one of the most un-PC movies to do a remake of. Like, honestly, how do you do a remake of that one?
It wasn't that bad, was it? I don't remember.
The relatively undistinguished fraternity house. There, I gave it a new title for nowadays. Okay, everybody, I'm going to start the show so that we can do this. Just remember that this first little part is going to be clipped out for the podcast. If you like things edited and cut down for a little bit more brevity, get rid of the trouble bits and pieces, make sure you subscribe to the podcast. Otherwise, this is being recorded live with all of its warts. So we are glad that you are here to join us for the science.
No warts.
No warts. I mean, I don't know. There's science involved in that. It's a virus. Anyway, we won't talk about that right now. Different subjects in science. Yeah. Anyway, okay. I'm going to do this thingy here that I do, and then I'm going to do the other thingy, which is start the show in 3, 2. This is TWIS. This Week in Science, episode number 984, recorded on Wednesday, August 28th, 2024. Stuck in space.
Oh, no. Is there like a countdown clock? Like
No, we need to
days
get
away
one.
from society.
I'm Dr. Kiki, and tonight we will fill your head with spaceships, WIMPs, and Pong. But first...
Disclaimer. I shot an arrow into the air. It fell to earth, I know not where. So swiftly it flew, my sight could not follow in its flight. NASA launched a dart above the air. It hit an asteroid, Dimorphos, there. So soundly did it hit its mark that millions of fragments did embark. Sometime later, in an oak, I found my arrow still unbroke. And now we all await the hour to see NASA's homemade meteor shower. Will it be a pretty sight? Will it bombard geese in flight? Time will tell if Dimorphos can best NASA's double asteroid redirection test. This and other sciencey tales next here on This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki, and eventually Blair.
And a good science to you too, Justin. Blair, who's almost here, but is there. And everyone out there, welcome to another episode of This Week in Science. We are back again, Dr. Kiki, Justin, and Blair, to talk about science news from the past week. All the things that we thought were fun and we just really want to share with you and discuss in lots of detail. Great detail, but not too much detail. Like enough detail so that Justin gets to work on time. We do a tight 90 minutes of show. We have stories tonight. I've got stories about stucktronauts, some frozen remains, grammar genetics or genetics grammar, some fruity bats, sweet bats, and Pong goo. Pong and an internal, it comes from inside, brain attack. What did you bring, Justin?
I've got dark matter, not so wimpy after all, megalithic mystery solved, and the NASA fireworks story.
NASA fireworks. Okay, yes, from your disclaimer. Can't wait. Tell us more about this meteor shower in just a few minutes. And in Blair's Animal Corner tonight, you can look forward to crocodile culling. I don't know, but maybe some antlions playing a possum. Lots of fun times always in the Animal Corner when Blair joins us in just a few.
Why am I always having to look up animals?
We've discussed the antlion in Blair's Animal Corner before. But yes, possum versus opossum. That is an international question. Everyone out there, if you are just tuning in, this is This Week in Science. We're going to be talking about science news tonight. And if you are not yet subscribed to us, you can find us on Facebook, Twitch, and YouTube. Subscribing? No. Live streaming every Wednesday at 8 p.m. Pacific time-ish. And you can also find us most places the podcasts are found. Wherever you subscribe, look for This Week in Science if you want to get us as an edited podcast. And if you want more information of stories and just general stuff, more links to subscribing to things, go to TWIS.org. That's our home. It has been for a long time. But now it's time for the science. Stuck in space. Yes, stucktronauts. That we've talked about it a lot. Justin brought it up. We've brought it up. What's going on with Boeing Starliner and with the astronauts that went up in Starliner to the International Space Station? Well, it is now confirmed. NASA has officially determined that the Starliner is coming back without its crew. It is going to make its way back to Earth and hopefully make it back safely. Will not be piloted by any astronauts, and the fingers are crossed by everyone that they'll be able to retrieve Starliner when it gets back to Earth.
Less concerned with that.
Yeah. Next question
more
is
concerned. Well, wait, but actually,
or next answer.
More concerned that it gets away from the space station safely. I don't care if it makes it back home.
Yes. Will it get away? Yeah, with the helium leaks and everything. Yeah. Will it? But
it could still be a threat to the space station. Like if it's having these intermittent thruster issues, it could move out a little bit, but then not far enough away, and then So there's all kinds of problems. So
there are many problems. But it's not going to have any astronauts in it. That's been the determination, and those astronauts are going to be waiting on the space station as now part of the space station crew as guinea pigs for long-term low Earth orbit space inhabitation. What does it do to the human body? What happens to the human body in space when you are stuck there and not prepared for as long of a trip as you ended up on? Don't worry about the International Space Station. They did a resupply mission. There's plenty of food for everyone. They have extra gym clothes for the exercising. Everybody's got a place to sleep. There's all that kind of stuff. The International Space Station, the Asteroid, they're probably very happy to have some extra crew people aboard so that the space science experiments that are going on have extra hands. There are extra individuals to take care of some of the things that had not been having other people to work on them. So it's probably kind of nice for everyone to have the help. But the SpaceX Dragon should be bringing them back in February of 2025. Now, That's going to be interesting as well because the Boeing spacesuits do not match the SpaceX spaceship spacesuit fittings. So the question now is, are they going to wear their protective spacesuits back in the Dragon capsule when SpaceX brings them back, or are they not
don't
going to? Or
understand.
will somebody make a fitting that will fix the problem so that they can have space? Apparently, there are spacesuits that they can't go between different capsule types. So this is an issue that,
But
we didn't know was an issue.
why? Not like, okay, that's fine. I get it. You built the space suits different for the different capsules. Why do they have to wear the old ones? Why aren't you sending up a new suit?
Right. Maybe
Like,
they've
how hard
already
is
decided
that?
on what's going to be in the packages
no
that are
sense.
brought. I don't understand any of the decision making. I'm not involved.
Well,
It's based on
but I
weight.
think
It's based on how much space, how they're able to do it. So yes. And
but
the question is also, if they are going to take 4 people up, are 4 people coming back, or are they going to just shove 2 extra people into the Dragon capsule? It seems as though they're not going to be doing that. So this ISS, which would have had 2 extra crew members in February, will not. Additionally,
it was 4 people, right? 4 people were supposed to come up. And the last I heard was they were planning on sending 2 so they'd have 2 spaces, which also means they have plenty of room for extra space suits. Like, how hard is it to come up with a spacesuit that fits into the chair that you need to ride back? Like, I'm
sure this is something that will be addressed.
Why is that like the stumbling
February.
block? Is the space outfit? Like,
space clothes are hard. Space is hard. This is all very difficult. This is unprecedented, everyone.
It's like a backup if something happens to the capsule. So, like, you could come back in pajamas.
Why don't the spacesuits work in both capsules? Why don't they work
that's
in
because other people designed them, and I
don't
get that.
care. Why is it not like USB-C? Why is it not like, as soon as you decide on, okay, this is the new port, everyone can make a port that matches, the things that match. You can
because this is the argument.
Shoot.
This has been the argument against NASA forever doing things, which is that, but if only one outfit is doing this, then
I believe though, but if NASA is
there's
doing
no competition, there's no design competition for better ideas.
If NASA's doing it, then they say this is the standard.
Exactly.
And if they haven't, then exactly, they haven't, apparently. In addition to this, though, this week also SpaceX was supposed to send the first privately funded mission into space, the Polaris Dawn mission. And this Polaris mission, since earlier this week, has been trying to lift off from the Kennedy Space Center, but due to weather, it has been grounded. The FAA has grounded Polaris Dawn, and there is a story link for this with NPR. I wasn't aware of, but I am aware of. Thank you for that link, Arnlor. But bad weather has been keeping SpaceX's mission for this week, the Polaris, down. The Polaris mission is expected to be really exciting because it's actually planned to be the furthest distance from Earth that we have gone since the Apollo missions. This launch is meant to go to a maximum altitude with the Dragon capsule of about 870 miles or 1,400 kilometers from Earth. It is going to be also the first ever private spacewalk that's going to be out there. This is funded by Jared Isaacman, who is a billionaire entrepreneur and is going to be crewed by Scott Kidd Poteet, mission specialists Sarah Gillis and Anna Menon. Poteet is from the U.S. Air Force, and Gillis and Menon are SpaceX engineers. So they've got a good crew of people, but they're on the ground and they're not going anywhere probably until at least next week, maybe longer. We'll see where it goes. Fingers crossed for this mission. And finally, the last update to all of this is that SpaceX additionally had, with this new mission, pushed off bad weather, but also had some helium leaks which is interesting because that was also an issue, a small issue with the Starliner capsule. So and there was also the most recent Falcon 9 rocket, which has been, the boosters have been reused and reused and reused over and over and over again for the very, very first time in 267 successful landings. A booster crash landed on the drone ship. So they're scrubbing the Starlink 9.5 launch from Vandenberg Space Force Base. They're going to be reviewing the data from the landing failure. It could be that we don't know what the issue is with why
I thought
this
it landed, but
booster landed.
I didn't see any of this. I didn't see
It
any
landed
footage.
funky.
But I
It
thought it
landed
landed, but then
funky.
just like tipped over into the ocean. Like it always looks like it should anyway. Like every
Yeah.
time I've seen one of these things come down, it looked like, okay, it landed, but how is it still standing up? Like it's on a raft on an ocean. Like what's it? How is this even possible?
Well, I mean, it landed. It landed and blew up. Is what ended up happening this time around.
It blew up.
Yeah.
Right.
So anyway, landed poorly, blew up, fell in the water. Both not as severe an explosion as some previous during testing landings, which were extremely violent in nature. There was a green flash around the Merlin engines before the engine section was engulfed in flames, and the booster toppled over and exploded. And this is according to Spaceflight Now from today. So there's a whole bunch going on. Boeing, SpaceX, NASA, astronauts stuck in space. Can we bring home our astronauts, our stucktronauts? Let's see what we can do. Maybe it'll be Blue Origin who makes the next flight up to bring them back. Who knows? I don't know. I don't know what's going on anymore. Tell me some science news, Justin. This is enough for this space update.
Okay, so the Lex Zeppelin, LZ, is an experiment that has been searching for weakly interactive massive particles, or weakly interacting massive particles, WIMPs. This experiment, the LZ, has 5 times better sensitivity than any previous experiment. And what's so interesting about these WIMPs, these weakly interacting massive particles, is that this is one of the leading hypothetical particles that could be responsible for, or even be the candidate for, dark matter.
I want a WIMP to be the thing. Yeah.
Yeah. And they've got this big hole full of special liquid so deep down that it's immune from radiation. And the only things that can interact in this giant tank underground are WIMPs. This is the only thing that should be able to interact with it. And so they figured, they built this, and there's actually a few of these around the world now, but the LZ is the biggest. It's the biggest version of it, most sensitive version of it. So they have now run for something like almost a year, and they have found nothing. No signals at all. So they have, it's not quite like, maybe their experiment just doesn't work. To keep themselves honest, they have made sure that the algorithm for detection in their giant underground tank is working. So they have a computer that randomly injects fake events into the data stream. 7 such events.
That's a great idea. Are we doing it okay? Let's put a fake thing in and see if we can find something fake.
Yeah.
Oh, we did.
The computer has generated this 7 times now. And all 7 times, the researchers spotted it in the analysis. They didn't miss one, and they didn't get one more than that in the almost year that it's been running. This is one of the researchers quoted here. On the one hand, there's a disappointment at some level that there's no WIMPs there. But on the other hand, it's like, okay, at least we did our job. It's a little bit defeatist.
But they have, or they're going to be collecting 1,000 days worth of data. So this is only a quarter of the runtime so far.
Yes,
Like,
this is according to Dan Hooper at the Fermi National Accelerator Laboratory. Just because the LZ hasn't seen WIMPs so far doesn't mean they won't show up in that more data. There's more runs. He likens WIMP searches to a murder investigation in which 10 out of the original 20 suspects have good alibis. And he quoted here saying, "The detective does not conclude that there was no murder. In other words, the null result provides us with valuable information." Which is true. Null results always provide information. However, this analogy, if you follow it a little bit further with the murder investigation, it's like in the opening scene of the murder mystery, the detective announces who the murderer is, points them out, only to find out they were nowhere near the crime scene, and yet maintains that they are the best and only real suspect. Well, other suspects without alibis are ignored. Okay. Researchers plan to gather the data, like you said, into 2028, tripling the size of the data set. But then, if no result, that's kind of the end of it.
Yeah.
Almost. If a detector were 3 or 4 times more sensitive, research is already dreaming up a WIMP detector that could reach something called neutrino fog.
Neutrino fog.
Neutrino fog. So if the detector were more sensitive, the problem is it doesn't make it necessarily a better detector because it would start to see neutrinos. And the problem with seeing neutrinos is there's a constant stream of them pouring from our sun, and it would just be data.
Well, it would be, but then it's also, we have neutrino detectors, right? So we have neutrino detectors that are specialized so that they can figure out what's coming from the sun, what's coming from nuclear reactors on our own planet, what's coming from other events in other places. And it's trying to find those needle in a haystack other events. That's the interesting part. So depending on what you're looking for.
The idea would be trying to build this to the edge of neutrino fog and then being able to classify out the neutrinos that you're detecting.
That you want.
But you really want not to see them at all, because then you're spending a lot of time analyzing, is it, isn't it, is it, isn't it, versus result, no result, which is a much cleaner detector.
Yeah. But in this situation, I think it's fantastic because it's narrowing the place where our wimpy murderer can be found. Yeah. Right. So
but
if WIMPs are there, if they're involved, it makes them, it's, smaller size, smaller energy mass level, smaller energy place to be found.
Yeah. It's the detector here that's the biggest, and there's a couple others in the world that are very likely not going to find a thing if this one didn't. It's already like 50-something million, which, I think is a drop in the bucket for doing foundations of physics research. That's fine. Build your other one. But also,
it's going.
Maybe in the background, start, cranking up those other theories that aren't getting funded. Put those out there.
Well, that's the way it works. They're already cranking away. They're trying to get new experiments brought online all the time. They're trying to get new machines and new technology developed. You have to work probably about a decade ahead to 10 to 20 years ahead of where you want to actually be, because you have to first ideate, you get the funding, then you build, and you do. So everything is in a constant, having this here now that we're looking at the results of this experiment. This is something that goes back further. But yeah, they've got the money, they've got the people. Yeah. Keep it going. What else can they find?
But that's the thing, is I don't think there's a thing to find. This is again crackpot Justin physics.
Uh-oh.
But what we're talking about
This is why they're looking.
What we're talking about is looking for mechanisms related to gravity is still what we're looking for. Even though it's dark matter, the reason we see dark matter is because we see gravitational effects of it in the universe. Galaxies don't have enough mass to explain the gravity. Okay. Maybe your theory of gravity is wrong because we don't really know why gravity in the first place. And we already have dark matter that explains why more gravity. Hang on.
We don't know
fundamentals. Anything. You start with the basics. First, you got to learn how to dribble before you worry about alley-ooping and behind the back passing and all this stuff. Learn to dribble. Otherwise, you're not going to basketball analogy.
That's what this LZ detector is doing. It's figuring it out. It's tuning up the theories. This is yes.
But there's I don't know. I still think that there's a lot of
then there are other alternative hypotheses.
Yeah, and it can just be that your math makes sense that there should be a thing, but there might be also very wrong can also be still on the table. Anyway, good luck for the next wimpy detector that gets us into and they're going to put it so close to that neutrino fog that even if they find something, there's going to be like a debate for a decade about whether or not it's neutrinos.
Oh, that's
what slipped into the.
They've been looking at neutrinos for a while. They'll figure. I have faith in these researchers. The work they're doing these days. It's not going to be like the what was it? Faster than light particles that were really actually were a plug or a cable in the experiment at CERN.
The tachyon short circuiting.
Yeah, exactly. Anyway, they did figure that out. They're scientists. Did you plug it, unplug it, and plug it back in? Anyway, researchers are also not just looking into the future. They're also digging into the planet to figure out what happened in the past. How much of our history is frozen right now and will eventually melt? And how much of it can we access before it melts and goes away and we lose those incredibly frozen data sets? Researchers
that is a huge problem right now because it's not just like in a completely glaciated areas, but there's like huge swaths of land that are tundra. They're just almost always covered in snow. And they have been finding there's like a site in the Yukon, I think, where they keep finding sites of early human exploration in the area. But they're finding actually even sometimes wooden artifacts. The problem is the snow is melting so fast. And this is also happening in Norway, where they're finding evidence of
some of it we're finding because it's melted.
This stuff is melting and they're finding stuff. But then there's a clock that runs once that's been exposed before it deteriorates because it's been preserved by the ice.
Right. And so researchers from Ohio State University and the Ice Core Paleoclimatology Group have been working for years on an area in China called the Gulia Ice Cap. And the Gulia Ice Cap is this incredible 308.6 meter ice core. Well, they've got an ice core from this cap. This ice cap is in the far western Kunlunshan and the Qinghai Tibetan Plateau in China. It resembles, according to this project overview from the website of this research group, resembles a polar ice cap. It's surrounded by vertical 30 to 40 meter ice walls and has internal temperatures of -15, -5, and -2 degrees Celsius at 10, 200 meters and the base, respectively. The 308.6 meter core to the bedrock is the first high-resolution ice core of the last glacial cycle as recorded in the subtropics. And this was first reported in 1992. They've been looking at it ever since, and they have a new paper out this week in Nature Geoscience in which they are looking at viral communities within these ice cores. that they've recovered from the Gulia Plateau. And every time I say Gulia, I think Julia Gulia. It's not like, anyway, from Seinfeld, I think. Anyway, back to the 90s. This Gulia ice cap is this beautiful, desolate, frozen scape that is melting. And so being able to have these ice cores now is very important. And to preserve the ice cores is allowing researchers a real view into the past. And in this particular case, the researchers were able to look back over 40,000 years of viral evolution through the ice cores that are found in this ice cap, which really is like, it's like a cap. It's like if you were to take a little cap, a pillbox hat, a cap, and stick it on the ground. That's kind of what this is. It's a chunk of snow that's very large that hasn't melted all the way yet. The researchers are able to look back. They find sedimentary evidence. It has many layers that can be matched to geological cycles. So they're able to match the timing of certain events throughout history to layers within the ice core. And in this, they were specifically able to look at these viral communities that were preserved and determine that the viruses over the last 40,000 years went through periods of growth and population change, and they're probably influenced by season, as they found summer and winter seasonal shifts in the ice cores that suggest that there is some amount of that they're through history that with thawing and freezing and thawing and freezing and whatever those summer and winter cycles are, that possibly with winds and rains, that different bacteria and different viruses were brought in from other areas to this glacier core area in China, and the viruses were able to infect their bacterial host. These are microbial viruses that they're looking at, and they're able to see that the viruses infected the bacterial hosts, often stole metabolic genes from the bacteria to be able to enable them to hijack the bacteria and take over, and then didn't just kill their bacterial hosts, probably help them to survive during the winter months and during different summer months, depending on.
That's a good virus.
Yeah,
That's a good helpful virus.
Not necessarily all viruses are bad. They don't always kill their hosts. In fact, it behooves them very often to hijack the hosts in order to survive themselves, to propagate as a non, quote unquote, metabolically living form of life. Viruses do depend on their hosts for survival. But then again, everything on Earth depends on everything else for survival.
True.
Yeah. But the interesting aspect of this is that there were very definite populations. Many of them were not related to populations that are known now. There was a lot of relation to viral genomes that are fairly common around the Tibetan Plateau region, which is and through have been seen throughout historical records. But they did find a number of genomes from their metabogenomics, right? They're looking at a big set of all of the genomes that were present to see what was there. And the big set that they looked at, they determined that there was a little bit of spread around the globe, but really it was very centered locally, and a lot of the variation is not represented in anything that is alive today. So there were a lot of differences between the viruses 40,000 years ago and the ones that we find now. So there were a lot of different genes that were active in those species. Yeah. Lots of new species. Oh, there it is. Thank you, Joe Nunya. Julia Gulia is a character in The Wedding Singer, wasn't Seinfeld. That's right. Thank you. Thank you for correcting me. And Blair was going to correct. She would have corrected me if she were here.
She's here.
She's lurking. I hope the baby's doing well. Yes, it's sleep time. But we're still talking about science. Yeah. So anyway, 40,000 years of glacial ice cap and bacterial viruses, microbes that put a lot of viral evolutionary pressure on the species of bacteria that they inhabit, that they hijacked, that they took over. But once again, it really, the take-home message is there is a line of commonality that does compare to the microbes that are and bacteria, the viruses, bacteria that are found in glaciers today. But there's a lot of differences as well. And there could be a lot of information in there that would be really important and interesting to understanding the metabolism of different bacterial species and how we can use that to our advantage in different ways. There's a lot of information there. And it could be lost. It could be lost, but it's not lost yet. It's still in an ice cap.
It could also wake up and reinfect bacteria. Because apparently viruses don't care how long you're frozen.
Viruses don't care. The metabolism of a virus is not their own metabolism. That yes, we'll see. I don't know. The virus has a viral capsid, usually a cap, but anyway, yeah, we'll see. If things thaw out, how much actually makes it into the new times, which we've talked about before. But luckily, there are places like Ice Core Paleogenomics at Ohio State University where they are working to be able to figure out a lot of these things for us. Justin, did you want to talk about anything? Or do you want me to jump into my next story?
Dolmen.
You go ahead. Megalithic. No. Tell me.
Yeah. So this is a new look at the dolmen of Menga, which is a megalithic site in southern Spain. Some little background. This is a 56 to 5,800-ish year old site. It's a stone structure built into the side of the hill. It's one of the biggest of these megalithic stone structures ever discovered. Has vaulted ceilings, plenty of room to entertain a large gathering. Picturesque. Picture Stonehenge.
Mm-hmm.
But then the stones are bigger, and there's no gaps in between them. Right. So all those standing stones, all those stones forming walls around the entire enclosure. And then on the top of it, much, much bigger stones. There's that cap the whole thing. One of these capstones, these roof stones alone, weighs some 150 tons, which is that's like the weight of a blue whale. It's like 150 tons.
So technologically, how did they do this? How did they work with these stones to build this huge structure?
So first of all, they had to invent pillars, because inside of the structure there are pillars that are also helping to hold up the roof. And then you're sharing an image there. Hold on, that one there. That opening, which is the entrance to the dolmen, which goes back. I mean, it looks like it's just a little cave entrance, but it goes back about 20 meters.
It's a nice and a nice space for meeting your guests when you've invited them over for the evening.
6 meters wide at some of the wider parts. There's a well that's 20 meters deep built into it. So they have pillars. There we go. They had to invent pillars. That's not a thing. Also, these stones that are making up the walls, many of them are actually dug out the bedrock below the structure before placing them, so that it's actually sitting on bedrock, so it's much more secure as a foundation. It's just really kind of an incredible sight. So let's see, where was it? Okay, so the deep well for holding water, I guess. It had an earthen roof that could protect the stone from weathering, because this stone is mostly, if you look for this story anywhere other than a scientific source, they were like, how did the ancient people carve the stone? Like, it's sandstone. You can carve it with a child's playground.
Isn't that one of the things
shovel.
that kids do as art projects? Make a sandstone sculpture at some point.
Yeah. So
least in
but
California.
covering the roof with this sort of with earth and stuff, it prevented rain damage and that sort of thing. So they knew to protect the stone. This is also in earthquake-prone areas, so the fact that it's still standing pretty much intact after 6,000 years
means they did a good job.
Makes it one of the best-built structures mankind has ever made. It had to invent the arch and the pillar, and then, of course, it was lost to history. So it's unique for several reasons.
Until somebody found the hole and dug up the rocks.
Say it again?
You said it was it was lost for a long time. I was like, until somebody found the hole, until someone found the rocks and dug it up.
So it hasn't been dug up. That's the amazing thing. It's been
They found it. They what's this piece of sandstone? Oh, look, there's a hole. Don't fall down the well, Timmy. Oh, wait.
Oh, the well itself. Yes, but this has been used. They think some of the lower sides of some of the stones have been worn away because people were keeping sheep in there. Sheep herders would use it as a place to keep the sheep safe overnight from wolves or something. All right,
it's just a nice cave.
So it's unique for several reasons. It's got pillars that support the capstones. These were embedded in the bedrock. Also, the stones are wedge-shaped. So some of them are narrow at the bottom, some are narrower at the top, and they're put in an alternating pattern. So they're actually kind of interlocked all the way around, which creates an incredible amount of stability there. And again, the world's first arched weight displacement as the walls are slightly tilted in, causing a displacement of weight from the capstones above. So there was a multidisciplinary study that was not just archaeologists, but it was made up of physicists and geologists and people who knew geometry, astronomy, all the different fields. And they came together and looked at this from a bunch of different perspectives. And they kind of came up with an idea of how they think this was built. They think they used wood sleds because rolling timbers or something like this would have been maybe too rough on sandstone. The actual carving out of these stones, they didn't really seem to change they were as far as about a kilometer away. So far, but not super, super far. So they were pretty close to the source of the stones. And I think they used wooden sleds and a counterweighted ramp method to lower the stones in place so that they would be able to drop them with millimeter precision-ish right into the locations that they wanted to.
Using a bulldozer.
Well, using actually a lot of wooden support structures. So again, this is we're talking about Stone Age, Neolithic Stone Age. I guess it's almost into the Bronze Age.
It's basically a wooden sled. They used a wooden sled to put the big stones on, right? As you're carving out the stone, you let it fall onto or push it out onto the piece of wood, and then you're able to use, rolling rocks or lots of people or oxen or I don't know, lots of sheep.
Could be lots of sheep
to pull the sled, right?
Yeah. The studies suggest that these people actually required an advanced knowledge in fields of geology, physics, Also, some of the orientations required some astronomy. I mean, this is also some of the dolmens are. There's one that's close by that's a little smaller, but the light can only hit this back wall when we get to the solstice or something like this. So they've got like a lot of interesting scientific understanding built into the structures here. So yeah, the many features of the opium atrium gives way to a rectangular shaped back section, acting as a corridor leading to an oval shaped chamber in the rear. And included is this 20 meter deep well, which means they could have kept water. So for the ancient modern cave person who wants to have it all, this would have been quite an extraordinary sight.
Absolutely.
I can't wait for Indiana Jones to show up and fight some Nazis over something inside.
Yeah.
It really feels like what you're describing feels like one of those Indiana Jones puzzles with the light hits the feature just right at the full moon, and then
But to be able, to build it to such to such architectural standards, right, and spatial standards, and forever it's like, how did they build the pyramids? Aliens? How did they do this? Why? Just people know things. We're animals.
Yeah.
People are smart and have known things for a very long time. We just didn't have the written word or the internet for much of our history, or at least if there was writing or sharing of information in some, shareable form, it wasn't something that was preservable that we could find.
Well, yeah, if you didn't graffiti the walls of a cave, it was lost. If it was on paper, if it was etched into wood planks.
But if to think about those Socrates and ancient Greek philosophers who, the book was what they wrote, and then they kept it in their head. And then you would copy a book, you'd copy a book and learn it and keep it in your head. And then you'd share that with other people, and you would keep the books in your head. And that is how many, you were the library. You put all the books in your head. You were the library. And then Socrates, you talked to other people, and they shared their books with you from their head.
And Socrates famously wrote nothing down.
No, that's exactly. You were the book. The idea was that by incorporating the book into your noetic consciousness, the information could be combined with other information more
tribal
readily.
knowledge. Yeah, tribal knowledge. It's everywhere. The amazing thing here too is that despite the difference in the heights of these stones and the wedges and going down into bedrock and dug underneath, the tops are pretty much on the same level.
Yeah.
And which is how the capstone is able to fit over the top,
right on top,
in place. And it's also kind of interesting, like this all of this scientific knowledge that's lost. This is also 6,000 years ago, southern Iberia, Spain, is a population that they don't think contributed to the current modern world in any significant way. So this may be a brilliant population that vanished from the earth, that had it all figured out early, and then just got conquered, or something bad happened, or got sick.
Aliens,
or all drank out of the same well water for too long.
That seems like a crazy thing to say, that this entire civilization, they didn't really contribute anything though, so don't
How many times have things been underestimated? Always.
Yeah.
Well,
you're telling me nobody came by and then took information back to their tribe,
No, what I meant was like the Y chromosome from a lot of this time region in southern Iberia did not progress to the future. There's some relation to Basque people from other areas, but from my understanding, at least the ancient genomes of Iberia in the 6,000 year range.
They were pretty. They're pretty treacherous mountains. So
they were most likely, originally Italian migrants from earlier that came, and then, but there was all sorts of different waves of people coming into Iberia from 6,000 to about 2,000 years ago. But most of the earlier ones do not seem to have contributed to modern gene pools, and they don't know why. They don't know what happened to them. Something bad.
What happened to the Iberians?
Something bad. Or
they all moved. What?
Something bad. I don't know what it is. But they were brilliant, and that's probably why. Nerds.
So many nerds here. Blair's here. Welcome, Blair. Thank you for joining us.
Hi, Blair.
Hi.
One last story for this first part of the show before we get to the second part of the show, and or actually maybe Justin, I don't know. I'll do this one.
Yeah.
You have time for one. You'll jump in a second. One last story. Researchers just publishing in Nature this week from Washington State University and University of California, San Diego, have been looking at the genome. And oh my gosh, people have been looking at the genome for a very, very long time. But this time they looked at genetic sequences called transcription factors and where they are located with respect to the genes that we think that they control. And so transcription factors are little genes that create, when they get turned into things, they create proteins that then control activating the transcription of a gene within the DNA. So it's basically their control factors. Turn them on or turn them off. So are they activators or repressors? So we have repression and activation. That's what we've always thought, that it's one or the other, but not that they could be kind of both, or what's happening? Anyway, maybe new genomics textbooks. That's what they're saying. It might be hyperbole, but the researchers in this particular study have determined that the spacing between where the transcription factors are and where the gene's transcription starts determines the level of gene activity. So if a transcription factor is in front of the gene's start point, then usually that is an activator. If it's after the gene, then it's usually a repressor. And if it's far away on either end, that means it has either less or more influence over the transcription of the gene, whether or not it's activated or repressed. So in their study, they found that, they thought if you take out an activator, you're going to lose activation, but they found that was only true in about 50 to 60% of the cases. So then they started looking in deeper, and that's when they determined that, this same transcription factor that we took away from the front part of the gene actually is over here also on the other end of the gene and kind of far away from, so it's turning the gene off. Or there's another one and it's over here. We didn't take the right one out. And so it's still the gene's still getting activated, even though we thought we shouldn't be doing anything, because there was another transcription factor that was placed differently. And so the key here is now we can read those little letters that are in the genetic code, but it's what they're calling is genetic grammar now. How do we know how to read the paragraph to tell the story to actually make all the genes work?
I love that there's a backup plan within the genome. It's like, well, we want this gene to be on, so here's the on switch. But just in case, down in the basement, we got another switch that can turn that gene on, just in case the main switch fails.
Yeah, we could put it over here. We've got extras over here, but they looked at all these different transcription factors and definitely found that position and how close it is, and there's all sorts of details to where these factors are located with respect to the gene that go into telling the genetic story. How do the genes get expressed? Yeah. Dun, dun, dun. I will keep us moving on this show. This is This Week in Science. Thank you for joining us for this wonderful episode of This Week in Science. If you're enjoying the show, please head over to twis.org. Click on the Patreon link if you'd like to become an ongoing supporter through Patreon. The Zazzle link if you want to support us with a little bit of TWIS merchandise purchasing. We've got all sorts of cool things that have been created that help keep this show going. Additionally, there are show notes and other things over there and links for subscribing. So if you're already subscribed to TWIS, you can also send someone to twis.org and get them to subscribe today. That would be super awesome. All right, we're going to come back right now, and Justin has one more story before he heads off. Dun, dun, dun.
Off into the world.
Work.
So,
Yes.
This is from the disclaimer, NASA's DART mission. This real just so it hit asteroid Dimorphos back in 2022. As the initial reports came out, it looked like it was just maybe a little bit of dust came off of the asteroid, and then there was like more detailed information that came out later that might be slightly more than just dust. On this show, we had some hot takes about what that might mean initially. Kiki was saying, this is not increasing danger to humanity. Justin saying, this is going to be a terrible movie. And Blair prophetically stating, whoops.
Blair's often prophetic in that way. That's good.
Well, the initial reports were of dust, not debris, being released from Dimorphos. There are fragments and chunks, after all, that have separated, millions of them, some of which will be colliding with the Earth and Mars over the next decade. So, the ones that hit Mars, probably not a big deal. Earth, on the other hand, is where all the humans are, save a few put aside by NASA, however tenuously. But the current news reports, based on current study of the aftermath of NASA's double asteroid redirection test, suggests that we will encounter within the next decade or so the debris from the asteroid.
That's soon.
So far, it seems like this will result in little more than a meteor shower. Light sprinkling of homemade shooting star dust.
Well, it's dust, but there's boulders in there too, right? There's pretty big chunks. But
you know what? So I did. It's kind of funny. Like, you've got did you show when you Google?
I know it's fun to Google
the
this.
It smashes the screen.
Whee!
Okay, so I put this. This was actually my link to the story. Is just news stories about this. Because if you go to NASA's website, they're like, we're not even going to mention it.
Well, I mean,
you're like, it's
NASA is so bad about reporting. NASA is so bad at reporting about NASA. Can I just mention this? Like, they do their updates, but they don't have any information about this trapped astronauts on the website. They don't have any information about the debris field from Dimorphos' story.
These stories are not necessarily so far. They're letting the narratives get spun and potentially.
They don't talk about NASA at NASA.
Yeah.
They don't talk about. They talk about future missions. You can find page upon page upon page of future mission or past mission.
Yes.
But what's currently going on? It's kind of really lacking current. News.
What's happening currently is the 2030 plan, which is really taking NASA apart, which is kind of wild. It's been going on for a while. There's a whole restructuring of NASA that's happening. That's what they're not talking about, but we're not going to talk about that.
Don't know anything about it.
Yeah, it's a whole plan that's out there. It's all been putting everything to contractors. More to contractors. Making
you
NASA
feel like that's
project
really well so far, for sure.
Do you feel like, do you feel like that argument, though, is going to get backtracked after, like, one of the biggest that they wanted to rely on completely failed? Another one is showing some failure. Like, I don't know.
We've had lots of great. They do a great job of Actually, their communications teams do amazing jobs of communicating, and they're getting better. They're getting better.
NASA's?
Yes, they're getting better.
Unless you know somebody who just got hired there.
The James Webb Space Telescope has been talking about stuff and did a great job of keeping us on, like, hooked to that news story for 20 years. Is it going to work? Is it not going to work? It was an ongoing story for 20 years. Every time there was a new story, I was ready for it.
And they rolled out by having administrators droll on in the worst Carl Sagan.
Well, it is the government agency. But yes.
They're so terrible at communication. They're just actually there was one person who did a very good job doing that.
But I do hope in the next decade, this one, DART, they tell us more. They have what, a decade to let us know, as they do have
how bad it will be.
Planetary protection minister or whatever. There's a role.
I feel like NASA's downplaying. Maybe that's what they're talking about. Maybe that's what these meetings are about. We're going to take this away from you, the decision-making power, because you just sent an asteroid at Earth. Yeah, we were going to wait to talk about it like 10 years from now.
It's a big, like, rubble pile that it's like throwing a handful of, I don't know, backlot dirt at somebody during recess.
And this one actually looked like a rocky asteroid. Like the pictures of it, like it looked like, oh, finally we found an actual asteroid, not just a floating gravel pit.
But it is a floating gravel pit.
Pile.
Yeah.
All right, I gotta go. Great show, everybody. Hi, Blair. Bye, Blair. Good night, everybody, or good morning, wherever you may be.
Have a great day, Justin.
All right.
Thank you. Don't get asteroided. Blair, you are here.
I've made it.
You have made it through the trials of motherhood.
For today.
The treachery of bedtime.
I live to survive another day.
And you shall win. Well, hopefully, just survive until tomorrow. We'll keep it going. And in the meantime, thank you for joining us, because you're just in time for that part of the show that we like to call Blair's Animal Corner with Blair.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels.
What you got, Blair?
Oh my goodness. Well, let's start with some upbeat news about crocodile culling, shall we?
That sounds a great place to start.
Yeah. So, Australia, they're full of dangerous things. And we've talked before about shark culling and how it's very popular to talk about that in Australia. But apparently crocodile culling is also on the menu. But I assumed if you lived or traveled to Australia, there was just an understanding that everything could kill you. And you're moving into their space. So this is no surprise, right?
No.
But there are occasionally issues between saltwater crocodiles and humans. And so this is specifically looking at saltwater crocodile attacks on humans in the Northern Territory over the last 50 years. And there was this big data analysis. And they showed that between 1979 and 2022, there were 76 crocodile attacks in the Northern Territory. And 30% of those were fatal. So that's not nothing. And if you knew that person that was killed by a crocodile, that sucks. The kind of like, I'm not even going to say but, I'm just going to say it is also important to note that
didn't mean to laugh,
over 50 years, 76 people is actually not a lot of deaths compared to all the other ways people die in the world. But
yeah,
all that aside, like you're more likely to die from a cow than from a crocodile. But
right.
all
And
of that aside,
where is this also in comparison to shark attacks?
right. Shark attacks worldwide, you get about 10 deaths a year from sharks.
So crocodiles,
So,
this is one
so that
continent.
would be more.
This is
Yeah,
crocodiles, more dangerous than the
right.
sharks.
Right. And so the rates of attacks they found in this data analysis stabilized in around 2009, despite the fact that crocodile density and human population continued to rise. And in fact, there was a 10% decrease over the following decade in attacks. So, what happened? Why, despite more crocodiles and more humans, was there the same and then actually less attacks? Again, the crocodile population was going up, so there was no culling happening, there was no removal happening. Instead, there was a giant effort to educate the general public.
I was
It was
wondering if
part of
that's what it
a
was.
yeah, it was a Be Crocwise education campaign between 2013 and 2016. The Northern Territory government spent about $250,000 Australian dollars on the Be Crocwise education campaign. And since their implementation, there was a 10% decrease in the frequency of crocodile attacks. Now, meanwhile, there are proponents asking for culling of these animals. And the same data analysis showed that in order to reduce the croc attack frequency by 1 attack per year, they would have to reduce the population by 90%.
Oh, wait. Wow.
So
This does not seem like, I think the education campaign seems like it had more beneficial payoff than culling 90%
yes.
of the crocodiles.
Yes.
Cost
So
benefit
they would
analysis.
have to cull 90% to reduce 1 attack a year. Okay.
Wow.
So now if you're removing 90% of a species, first of all, that's very expensive. They think it would cost about $975 per crocodile to humanely destroy them. Just the cost of destroying each crocodile. That means it would cost about $87,750,000 to cull 90% of the population humanely. And that, even if they did that, that would achieve a 48% reduction in crocodile attack frequency. And yes, those numbers all make sense. That would be so removing 1 crocodile attack a year is a 50% reduction in the attack frequency because there was less than 100 attacks over 50 years. So, so all of this to say, it's a couple people a year. So anyway, all of this to say, very complicated. Not as
So, but why? I mean, when I hear kill 90% of a population, I think, okay, is that population, is it like the crows in Portland where there's so many of them? Why are there so many? Like, is it
right.
populated? Is it like one of the reasons that we have deer hunting so that we manage the deer species so that they don't eat all the vegetation, right? So that the
Right.
ecosystem stays working. Is
So
90%, what does that do?
right. My understanding is crocodiles, so first of all, endemic. They are supposed to be in Australia. They are
As
part of
opposed
the
to
local
the
ecosystem.
toads.
Right. Right. There was a whole story about them that I almost brought last week and then I didn't. Anyway, yeah, so they're supposed to be in Australia. On top of that, in the 70s and 80s, worldwide, crocodilians were being killed for their skin and their meat and to just get rid of them because they were getting in the way.
Mhm.
And then there were protections put in place. I don't know exactly what the protections around saltwater crocodiles in Australia is, but I know that in the United States, alligators became protected, right? And so
Yeah.
just worldwide, I think there was this understanding in the 80s and 90s of, oh, these animals serve a function. And so that's the other piece of this. if you have to actually remove 90% of a species that is endemic, that is supposed to be in a space
What
ecologically,
happens
you are
ecologically?
you are making them functionally extinct. You are making them absent. Their ecological impact is now absent in that space. And
Mhm.
I know for American alligators, they completely changed the character of swamplands, because without alligators sloshing around in the mud, there weren't little divots for baby fish to grow up, right? And so they are architects in their space.
Mhm.
Crocodiles, they do a
Yeah.
lot of that. They also control prey populations. They're and if they mix up mud, if they're shimmying in and out of the water, that also creates more cloud cover in the water for animals to hide. It stirs up nutrients. There's all sorts of things that they could be doing that when you remove a large quantity of them, it would throw the ecosystem out of whack. So, I mean, this is a
Yeah.
very long, well thought out, well studied article about, hey, you can't just remove animals because they're in the way. And instead, maybe what you need to do is educate people in how to live near those animals. And so,
But if those
the
saltwater crocodiles are living in areas that are potentially attractive to human living development, so is it close to coastal areas? Is it,
right,
are they in places where people want to build condos, apartment complexes, big old fancy houses that would make people money, and they can't because the crocodiles are there? Then kill them. If you get rid of them, I
right,
can build things.
right. So their goal, and what was very effective, was just general education on how to act around crocodiles. Then also
Don't be near them.
changing behavior around specific problematic waterways, so posting signs, closing recreation in certain areas. And then the third piece is really important, which is removing problem crocodiles. And that is, for example, what we do in America with bears. There are still quite a few wild bears, not in California, although we do have black bears here. We have quite a few black bears in California. But throughout the United States, there are still bears, which is crazy to think about. But part of the reason that that is able to continue is because when there are problem bears, they get removed from that space. So you don't go, all bears are bad. You go, this one bear keeps breaking into this one farmer's grain silo and threatening his family. So we are going to remove this one bear from the equation. And that works. So think about the cute bears and just apply that same logic to the crocodiles. Well, I
They're
think are
cute
very cute. But,
and who are very smart and have been around on this planet a heck of a lot longer than we have. And maybe their place in the ecosystem in Australia as tree climbing organisms is to kill the drop bears.
yes, the drop bears. Well,
Yes.
the drop bears are also, they have their own problems, So
Yeah,
we're
I know.
actually trying to save the drop bear right now.
Save the drop bear. Okay.
Yeah.
Good to know. Good to know.
Yeah. Anyway, and my final story for the animal corner tonight is all about antlions, which are a type of insect that I spent a long time going, what are antlions related to? They're just
Mhm.
bugs. Just let it go. They're just insects. And don't come at me if you're like, they're not true bugs. They're okay, fine. They're insects. Anyway, their so their larvae are really interesting because they are predators. As larvae, they will catch ants in little like divots that they create in the sand, which is one of the reasons why another name that they have is doodle bugs, which I think is very funny because they write these like little doodles in the sand and then the ants get caught and then they can eat them. Anyway, that's not what this story is about. The story is about the fact that antlions also play dead. And how did University of Bristol scientists figure this out? Well, in a previous study, they had to weigh them. And it's really hard to weigh larvae because they're squiggly and they're really light. So every time they move, they might shift by a half a gram. And then you're like, I can't get a weight on this guy. So I would love to have been there when they figured this out. But when they found out that when they drop the larva gently onto the pan of the weighting balance, they remain stationary. So was somebody really mad and they were like, I'm gonna drop you, you'll see, or like did they slip, whoa, and then drop the like what happened? How did they figure this out? Anyway, they figured it out that they suddenly went stationary. And I'm sure also the researcher was like, did I kill it? And then at some point, the antlion started moving again. So it turns out they were playing dead. They also noticed, they noticed that they were able to stay stationary long enough for them to be weighed accurately.
Oh, nice.
But they all stayed stationary for different amounts of time, and it felt arbitrary. Why was some antlion stationary for a couple of minutes and then woke up and walked away? Others up to an hour. Why? Why were they playing dead so much longer or so much shorter?
Why did they know to play dead? Why was that an instinct?
Mm-hmm.
Yeah.
Mm-hmm. So they found a distribution, and it was random per individual, random throughout the breadth of individuals that they had, but it had kind of a regular distribution when they mapped it. So they felt like it was there's a confine, there's an expectation, there's a normal length, there's more and there's less. And so there's kind of this like normal distribution of how long that they would stay out, but they couldn't really find a clear association. If this happens, then you stay out longer. So there's definitely more to figure out there. It was unpredictable. So what about this is predictable? Is there any specific correlation between a particular stimuli that makes them stay out longer or less long? So more to find out there. But the other piece is that the behavior that they would exhibit when they woke up appeared to have some plasticity to it. So they didn't act the exact same when they woke up all of the time. They didn't scuttle off as fast as they could every single time. If they were on fast substrate, for example, they would, when they woke up, tunnel down into the sand. If they were on hard substrate, they'd run away. And they wouldn't kind of take a second to figure it out. They just kind of go. So it was almost as if they like knew what they were going to do before they woke up. And so
they weren't really asleep. They were hiding, and then they were planning. Yeah. They're like, okay, I'm going to do this.
Watching? Oh, he's still watching. Yeah.
Yeah. Okay.
Okay. When he's looking over there, I'm going to run. Are you ready? And so they found some adaptability in these individuals based on whatever the predator might be, whatever the substrate they were on was. And so this is something that has not been observed in a lot of animals. And so this is one of those things where it's like, can all animals that play dead do this? Are there animals that play dead that we don't even know play dead? How universal is this experience? Also, how complicated is this behavior? If they kept doing other things, adding new variables into the equation, would their behavior differ? So, or do they have kind of like a very clear set of potential reactions to being attacked? And so that's definitely likely to come next. Studying antlion larvae is figuring out these constraints around how they act when they wake up, and kind of what the cause is, and if this is applicable to other individuals, other species.
Yeah, I mean, I think that's one of the big questions, right? Is the behavior something that is, of course, it's going to be genetically encoded, right? But why is it genetically encoded? Is it something that is, is it evolution convergent evolution, or is it something unique? I mean, we know other animals do play dead, and there are many reasons that they do, but when and where did this evolve, and why, and what are the controls around it? Yeah. Why play
And
dead?
someone in the chat room, Kevin, has said the motion of digging in soft ground and skittering on a hard surface is the same. Sorry. You might think so, but to a beetle, it is actually mechanically a very different action. And so if you're a beetle researcher or you're a bug researcher, you're an insect researcher, depending how specific you want to get about it or less specific, they can tell the difference in what they are doing. And it is a very specific motion, and they are doing it intentionally. So, yeah, definitely sounds like a doctoral dissertation incoming. And so through this, I learned that death feigning or playing possum or playing dead can also be called thanatosis, or it can also be called post-contact immobility. But regardless, there are more animals that do it than we thought, and it's more complicated than just lying there and waiting for a predator to leave.
Right. I mean, the fact that there is like the different behavior, and the different behaviors are physically, mechanically different, it suggests that there are constraints, or I wouldn't say reasoning, but what's going on? It's a little larva. What are they detecting? What do they know? What do they know about the study they're in?
Yeah.
I don't know. The antlions, of course, they're manipulating the researcher to their own.
They're like, don't look at me. I'm going to do nothing interesting.
I'm
gonna
nothing.
do the opposite.
I'm not going to do
dead.
anything.
Yeah.
Well, I wanted to talk about bats, and I know that I'm going to
let's hear it.
continue this forward into staying in the animal corner, and I know that you love the bats, and so I thought it appropriate to put this story here during the show. This last week, some research was published in Nature, Ecology and Evolution. It's open access, so if you're interested in this and the dietary evolution of bats, you can go check this one out. The researchers were looking into the question of how is it that fruit bats and nectar drinking bats, how do they deal with all that sugar? Like, how do they not get diabetes?
Oh.
Like,
why are they all diabetic? Or
What?
are they, and they should actually live way longer than they live?
There's that possibility as well, but maybe they are having a lot of higher mortality at younger ages. I mean, definitely they're, like some of the nectivorous bats, they have to do a lot of hovering, just like hummingbirds. And so, gotta get that energy, gotta keep that energy going. And one of the things that they brought up in this study is that, like hummingbirds, the nectar drinking bats they can't just get glucose from their glycogen stores. So like mammals, we store glucose, right? So we like make our fat cells, and that goes into glycogen. Glyconeogenesis or gluconeogenesis harnesses those fat cells, turns the glycogen into glucose, and so we can get more sugar out of our stores. Nectar drinking bats can't do that. They can't get enough glucose out of their own body to survive. They have to get glucose from the environment, from food in their environment. And this is the same as hummingbirds, which is some species of hummingbirds, which I think is very interesting. And there appear to be, according to the study, a couple of potential places where there might be convergent evolution at the genomic level. So genes for glucose mobilization and absorption from the gut. But anyway, these researchers looked at 22 different species of bats. And in this paper, they basically looked to see for the range of insect eating, blood drinking, everything eating, fruit eating, nectar drinking bats, all these different bats over these 22 different species. How do they tolerate glucose? How do they deal with it? What are they doing? So they took these species, and the first thing that they did was they tested them for their glucose tolerance. They just basically took their blood glucose levels, and in checking for glucose tolerance, they determined that, yeah, fruit bats and nectar bats are way better at dealing with glucose than the other bats. So they looked at uh, trehalose, sucrose, and or what was it? Yeah, trehalose, which is a kind of sugar that comes from an enzyme, so a breakdown product of enzymatic action in the gut. Sucrose, which again, there are enzymes responsible for turning, that's one of the two basic kinds of sugars, sucrose, glucose, fructose, sucrose. And sucrose is one of the basic kinds of sugars, but there's also enzymes that are available to make more of it. Glucose is the one that's like the basic sugar, and the researchers determined that the fruit bats and the nectar bats had really different profiles for how they deal with sugar in their bodies compared to the other kinds of bats. So what was going on there? Well, the next thing that they wanted to look at was, which genes were involved and how are things working at the genetic level or the molecular level. They also looked at museum specimens of the bat gut to see how the bat gut works, and how there were adaptive changes to the different species. And they found that from the omnivorous to the fruit bats to the nectar eating bats, there were lots of adaptations at the receptor level. So there were trehalase, or the enzymes for trehalose, so it allows that sugar to be brought into the body. There's sucrose isomaltase, glucose transporters, all sorts of genes that became active to create and basically allowed new ways of getting sugar from the gut, the small intestine, into the blood, so that right after fasting, when given a meal of sugar water, the different bats had different amounts of sugar in their bloodstreams. They got sugar in their bloodstream, and they survive very well because of these adaptations. And it appears to be that somewhere along the lineage, there's a whole group around from the blood-sucking bats to more of the omnivorous ones, where there were different adaptations for those sucrase isomaltase transporters and getting more glucose from the lumen of the gut into the blood vessels faster and better. So anyway, I think it's a pretty interesting study. Basically, all these bats have incredible adaptations that shows that their guts have adapted to the trait of just eating sugar, basically fruit nectivorous bats for sure. And there has been a slow adaptation over many years that's very, very prevalent and visible within the lineages of these bats. Especially, I think it's fascinating to look at the pictures of the guts. Here, I'll show you pictures of the guts. The fruit bats and nectar bats have longer guts with more villi for absorption than the other bats. They've got big duodenums.
So I understand. So there's some structural things going on.
Yes.
I'm wondering if there's anything. I'm only kind of joking about this. Is there anything that could be extrapolated from this for human pharmaceuticals? Such that, the joke version of that is, so I can eat nothing but candy all day and be fine. But the real version of that is, so we can treat people with diabetes or other issues.
Exactly. So what this shows so far is that there are specific adaptations to allow to just get the basic sugar, glucose, and more of it into the blood better for use by the different species of bats as you get to like the nectivorous bats that they really need that sugar for their activities. They specifically are the ones they've got direct transport between cells. It's just like, get the glucose out of the gut and into my bloodstream. And they don't have a lot of, they don't have insulin mobilization. So there's not a lot of like grabbing the sugar and then hiding it away for storage because they need it right now. Like it immediately needs to be used. It doesn't need to be stored. So, yeah, I'm sorry. I'm just turning down H Gaming. Hi, you're doing lots and lots of comments that are not helpful. Thank you for joining. But I find it interesting that they've adapted so much and there's just interesting changes. We're not going to be giving people bigger, better duodenums anytime soon, but maybe there are transporters. Maybe we can start looking at the genes that are involved in the gut and how different kinds of sugars are actually mobilized. We don't rely on sugar as much. We can store it. We definitely rely on it for energy, but at the same time, it can be too much at once is detrimental to the health of the organs of our body. So, yeah, I think the next question is taking it from the gut and into the blood. So it's like, okay, what is happening there? We see there are adaptations on the getting it from the gut into the blood side. And so now the next step is going to be, let's start really looking at what's happening in the blood and the adaptations that make it so that the cells are getting the glucose they need for the nectivorous birds. The ones that are fruit eating, they don't need as much glucose immediately. They can store it better. They get more energy from other sources. Omnivorous, especially, they can get their energy from everywhere. So they've got a little bit of everything. And what are the adaptations that are different there? How is insulin mobilized differently? Is it mobilizing differently? And how? Yeah. But knowing that there are these incredible differences between species is like just on that first step of getting it into the body, I think is very interesting. Also, a study from a couple of weeks ago found that bats, a lot of them, have glow-in-the-dark little hairs on the bottom of their feet.
What?
Yeah, totally out of the blue, weirdo little study. Researchers found, they were looking at Mexican free-tailed bats, and they found that they have hairs on their feet that fluoresce under UV light. And it was an accidental find.
Want to be stealth? That seems weird.
Yeah, and it wasn't just these Mexican free-tailed bats. This study from Science reported on in sciencenews.org. They talk about how it was an accident because the researchers had used a fluorescent powder. They were trying to see if the bats that they were studying, if they carried the powder with them to other places and if they could find it in different populations as an evidence of like mixing between the different populations. And they didn't find that at all, but they found these fluorescent hairs. And then they were like, those are weird. Let's look at other bats. And they found a whole bunch of different bats that have fluorescent hairs on the bottom of their feet. Why?
Yeah, why? Why would you want that?
Why do you have that? It's fancy, but why is that?
Answer
why?
me. Oh my gosh. Yeah, very strange. You'd think you'd want extreme stealth as a bat, but I guess
You
not
would
for the
think
footsies.
so. Yeah. So I think that's one of the, interesting, points here. So this bat, Mexican free-tailed bat, Tadaria brasiliensis molosidae, They have 24 individuals from 2 roosts in Mexico City, and they found 4 individuals of Myotis vellifer. The Myotis did not have these special footsies, but the Tadarida, the Tadarida brasiliensis, they did. So it's this species. They don't know why. Why are they photoluminescent? Some of them are longer and some of them are shorter. It seems like the outer toes have different kinds of hairs than the inner toes. Like the ones on the edge kind of have like a little bit of a brushiness to them. It's an interesting pattern that they don't understand. They don't know why. Why do you have these fancy hairs, little free-tailed bat? I mean, they're interesting as well in the shape of the flap of skin that comes from their rear legs to the tail is also a very unique morphology. So they're unique to begin with. But anyway, yes, little bats.
I don't know. I can't really think of. I'm going to be thinking about that one for a few days. Why?
Flashy bats. I don't know.
Why would you? Is that so you can like gauge when you're hanging upside down? You can see where your foot is going. I don't know. Very
Is it
strange.
part of how they talk to each other? Is it like identification? Is it, little something fancy, little fanciness? I don't know.
Yeah, I don't know. But ultimately, you'd still need a light source.
UV.
Yeah.
Photoluminescent.
So,
UV.
Right.
It glow in the dark, right? So they go out, but they're not out during the day. When do they get them all like or
charged? Yeah.
Charged, or when do they get them
That's what I was
charged,
thinking,
or when
'cause-
do they? Maybe it's yeah, I don't know. Maybe when they're flying around, maybe it's distracting to the insects that they're chasing.
Oh, maybe. Yeah, could be. Look over here, not at my face.
I have no idea. But yes, little fancy flashy bats have this photoluminescent structure. Nobody has any idea why, and it was an accident that they found it in the first place. A study gone wrong led to a study that became kind of interesting. All right, I'm going to take us to brains right now and finish the show on a couple of interesting stories. I've talked previously on the show about the brain in a dish that was set up to play the video game Pong, where they basically created an in the dish brain organoid neural network in which the neurons in the dish communicated with each other and were able to take in signals, electrically input and then output electrical signals from their electrochemical communication to the computer system that was connected to them. And brain cells in a dish were able to play Pong, and were able to play it pretty well. They learned, the brain cells learned how and when to expect the little puck from the little Pong paddle to end up in different places and could play the video game. I don't know if they're going to be like the Pong world champion or anything like that, but the question of what can be trained to play Pong led another researcher to this study that's just reported this last week in Cell Reports Physical Science. The researchers took hydrogel. It's like, hydrogel? What? That's just like a gooey substance that it's kind of biological. It's like, isn't it just stuff that's gooey and used in things a lot now? They're talking about using it in
conductive,
soft
right?
robotics.
Isn't that the deal? It's
yeah. Yeah, thank you for saying that. Yes. So it's got a lot of ions in it. It's conductive. And so this researcher took biogel, put it in a dish, and then basically distributed the dish into a 6-segment area. And called that the Pong environment. And so this Pong environment became the space that was electrically stimulated by a computer from the outside. And there was information about where the paddle should be, where the puck or ball position was within the Pong environment. Very simple 6-spaced grid. I mean, just 2 columns, 3 rows. Very, very simple setup. What happens in the conductance when an electrical signal goes to a particular area where the computer basically says the ball is here, that area of the grid was stimulated, or when the ball was in a particular area, that area was stimulated by the computer electrically. It conducted in that area. Ions kind of swelled that area up, so that hydrogel would swell up a little bit, draw water and ionic charge to it, and then the ions leaked away more slowly than they came in. So it kind of remembered, in a sense, where it had hit, where the ball had been, and then it would put the paddle there. It would then respond in that state. They went on and on. This isn't great performance, but from okay, you know where the ball is or you don't at chance, right? Just luck, 50%, 50-50. Eventually, this hydrogel, not alive in any sense, not able to, quote unquote, think about things, it was able to adapt dynamically to the input in a way that improved the effectiveness of its response. Because the ions move to one area and stay there for a little bit, if the ball was there again, it would make their response in that there, I'm saying there, it would make that little rectangle's response in the grid stronger and faster. So it improved efficiency of response for the video game, and the hydrogel started playing the game at 60% efficiency. And so the researchers are thinking, maybe this is like it's not memory, right? This isn't like but it is, and maybe not even programmable, but it's responsive and adaptive, dynamic. And so it could be used to improve the efficiency of movements or response times for little things that are maybe soft robots in nature, to movements that they have to make, that the robots must make in response to external stimuli. Not that they would be, that the little parts of the soft robot would be the part doing the decision making. There would be probably a computer leading that top down, but it would make it's like muscle training, right? You have stronger muscles or faster, slow twitch or fast twitch muscle fibers. You're going to be faster or stronger in a certain way if you train them. But this is potentially, the hydrogels can be used in a similar way. It's not learning. It's not memory. People are going to use these sensationalist words. Oh my gosh, Goo plays Pong.
This does feel like an argument, like at the college bar or something, right? Where like they taught the brain in the dish. Well, I taught a brain in a dish to play Pong. Oh yeah, you're not so great. I bet I could teach hydrogel to play Pong. Like this very much feels like a one-upmanship of things. Like that doesn't mean anything. Because it does kind of in some ways invalidate the accomplishment of the mini brains.
A little bit, but
it's a different system. It's a different testing system. It feels, the brains feel more like they're actually playing the game, although that's also still a bit of a stretch. This is still really hard for me to visualize, like what's going on in this goop. Like why can the goop do this?
It's really because because of the electrical charge and the conductivity. The conductivity occurs because of a shift in the ion concentration in different areas. And so, or there is because there's ion concentration. And so it changes the gradient. So when there's electrical stimulation and conductance in that region, it pulls ions in. With it, it pulls a bit of water, but the ions are more concentrated in one area than they are in others. And so another electrical charge coming back to that area again will reach threshold faster because there's already, a certain concentration of ions in that place. It's a shift in the
so that's helpful,
distribution of ion concentration.
Yeah, because I'm just sitting here like trying to figure out why the goop would want to have
Goop doesn't
the ball
want
hit the
anything.
paddle. Right? That's my problem. What's the motivation? Why?
That's just part of the programming from the outside. It's the system, the
and
circuit
so
that was
you
created.
teach it to do this thing, and even that word is wrong, but you teach it to do this thing. But ultimately, because the ball, quote unquote, is moving in a particular direction, it's changing the ion channels that are going that way. And so it's almost as if the paddle is drawn to that space.
Yes.
Again, paddle in quotes, but interesting. So I don't know if this goop really played Pong.
Right, exactly.
It seems like it did
it. That is the point. That maybe the goop did not play Pong, but it was involved in a Pong simulation circuit, and part of that computer circuit to make it possible. Yeah.
Okay.
Yeah.
I don't know about that.
I don't know. I don't know about anything on a reasonable point in time. But yeah, it's not it's not the same as the brain in a dish. It's not neural networks, but it is very, very simple optimization of the use of ion concentration and current draw, and the ability to optimize that within a system allows the potential for this substance, which is currently being potentially used for soft robotics, to offer a bit more in terms of when people think of how it can be used, how it might improve certain behaviors or certain actions by the robot. Yeah, just understanding the different dynamics that are involved. Yeah. Yeah, but yeah, it was a fun thought experiment turned into like probably a college bar night that turned into, let's do this experiment and prove a thing.
I'm gonna teach my plant to play Pong. Oh yeah, I'm gonna teach some goop.
Exactly. I'll teach the goop what to do. Dun dun dun. My last story for the night tonight is not brain goo playing Pong, but it is an attack in your brain from the inside. It came from the inside, or it came from inside your brain. Researchers for a couple of decades now have been looking into the concept of somatic nuclear mitochondrial DNA insertions. What does that mean? Well, it appears that throughout history, mitochondria, which has invaded our cells very successfully over the years to become part of our cells within the cell body.
They were eaten.
They were eaten, yeah, but they've also taken advantage of their situation. Every once in a while, when they start going a little like, I don't know what I'm doing, or during cell division, during reproduction, bits of mitochondrial DNA get shot out and thrown into the nucleus of our cell. So we have lots of mitochondrial DNA in our nuclear, in our chromatin, in our genetic, in our genes, in our chromosomes, from way, way back. It's been happening for a very long time. But the fact that it's really rare, it usually doesn't cause a lot. It's there because it hasn't mucked things up too much. Happens a lot before during reproduction. And during that period of time, if there's something wrong with it, you think that would be something wrong that would lead to the pregnancy not continuing, right? That it would be a natural abortifactive. That because would be something so wrong from the mitochondrial DNA getting into your chromosomes, that the chromosomes don't work right anymore. Well, it turns out that this like kind of weird mitochondria virus that we've got in our cells, that these nuclear mitochondrial segments that they're also calling numites, NUMTs, numites, that during our lives, when mitochondria start to go haywire over stress, when we're aging, when we're not nice to ourselves, that mitochondria start tossing their DNA into the nuclei of our brain cells. And they looked at numites from different parts of the brain, from tissue banked samples from over 1,000 older adults, and determined that the more numites you have in your brain cells, in the nuclear, the more likely you are to die, or that you know, these dead people, the brain tissue samples that they had, the people were more likely to have died from various problems. So it's not good to have numites. It's not good at all. But apparently, we've all got them already. But as we age ourselves, that the stress we put ourselves under, the damage that we are doing to our bodies, just in the process of trying to grow older gracefully. If you're not doing it so gracefully, you might be doing yourself more damage. And there's more of these numites in the prefrontal cortex than a lot of other areas. And so these are areas that are often hit very hard by things like other mitochondrial disease-related disorders, like degenerative dementia or Alzheimer's, or a number of other brain-related aging issues. So on this point, as it gets to be later and later, I say, let's look at our sleep and take care of ourselves so that our mitochondria stay refreshed and unstressed. And we reduce the probability of numites being tossed into our brain nuclei by the mitochondria that surround them.
Yeah, keep your mitochondria happy.
Right? Yeah. Keep your mitochondria happy, people.
Hey,
So
little
many things
powerhouse
these
of the
days.
cell. You keep
Yeah.
chugging.
I know. There's so many brain diseases and aging diseases now that we're looking at that are like, oh, that has to do with mitochondria. That has to do with mitochondria. That has to do with mitochondria. So metabolism, mitochondria, this is very, very important to make them happy, to keep them happy and good. And so everybody, let us be nice. Let us be very nice to our mitochondria, and let us say, have we finished this show, Blair?
Oh, yeah.
We're all done. All done for the night.
We've done it.
We've done it with the science. Be nice to your mitochondria. Go get some sleep. That's what we're going to do. Brains. Oh, Blair, you might be feeling the lack of sleep from having a child right now, and all the stress from work and all the things, and mom brain is a real thing. But apparently a lot of the studies looking at mom brain only look at mom brains when they're like within like the year or two after the baby's born.
Right.
Lots later. Big study out recently suggests that the long-term benefits of having a child is that your brain is strengthened. So it's like this period of time, you're pruning your brain cells for ultimate bonsai growth. You're going to be like, your brain's going to be a beautiful bonsai later.
You're under severe stress, so you're having to function on so little. It's like training in under severe gravity, and then you go to normal gravity and you're like, I'm so fast.
I'm so good. I can do
That was
anything.
when I was
can
running in
fly.
Jerusalem for 6 months every day, and then I came here and I was suddenly so good at running for a little while because they're at high elevation.
High elevation.
Over here, and I was like, oh my God, it's just like that. I'm operating on like so little sleep and so much stress that once that calms down, you're like, I'm a superhero.
Oh yeah, and then it's all gonna come back.
3 hours in a row after he was born. I remember I was like, I think I can see time. Like,
There's yes, there's something to be said for the places your brain goes on too little sleep. Oh moms out there. So let us all get good sleep, everyone, so nobody has any psychotic breaks, can see time, starts imagining things, or their hallucinations. Yeah, let's not do that. Let's keep our mitochondria happy. Get some good rest. I'm going to shout out to all of you out there. Thank you so much for joining us for this episode of This Week in Science. Thank you for being in the chat rooms right now. Hello, my Discorders. Hello, YouTube, Facebook, Twitch. Thank you for being here and chatting. I love seeing all your comments. And you're welcome, Kevin Reardon. Thank you, Fada, for all your help on show notes and social media. Could not keep this going without you. Gord, Arnlore, thank you so much for all of your work making the chat rooms happy places and nice. Identity 4, thank you for recording the show. And Rachel, thank you for editing. And as always, thank you so much to our TWIS patrons. I have to send a big thank you to all of you out there and read these names out right now. Thank you to Eden Mundell, Alan Viola, Craig Potts, Mary Gertz, Teresa Smith, Richard Badge, Bob Coles, Kenton Northcote, George Corris, Pierre Valazar, John Ratnasamy, Chris Rosiak, Vegard Chefstad, Donathan Styles, a.k.a. Don Stylo, Alec Coffin, Reagan Shubu, Sarah Forfar, Don Mundus, PIG, Stephen Alberon, Daryl Mychak, Andrew Swanson, Fred S104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, David E. Youngblood, Sean, Clarence Lamb, John McKee, Greg Riley, Mark Hessenflow, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Richard Brendan Minish, Johnny Gridley, Remy Day, G. Burton Lattimore, Flying Out, Christopher Dreyer, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Philip Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, Lon Makes, E.O., Adam Mishkan, Aaron Luthen, Bob Calder, Marjorie, Paul Disney, David Simmerly, Patrick Pecoraro, and Tony Steele. Thank you for all of you for supporting us on Patreon. And for everyone out there who might want to support us on Patreon, head over to twis.org and click on that Patreon link. Woo! On next week's show.
We will be back on Wednesday at 8 p.m. Pacific time, broadcasting live from our Twitch, YouTube, and Facebook channels.
And if you want to listen to us as a podcast, look for This Week in Science wherever you like to find your podcast. See if we're there. Put us in your RSS feed. If you enjoyed the show, make sure also to get your friends to subscribe so you all can talk about all the things that we talked about together.
For more information on anything you've heard here today, show notes and links to stories will be available on our website. That's at www.twis.org. And while you're there, you can also sign up for a newsletter that at some point, when you least expect it, will pop into your inbox.
It's going to be super surprising and fantastic, and you're going to love it so much. We do love your feedback. If there's a topic you'd like us to cover or address or a suggestion for an interview, please let us know on one of our social media accounts or send us an email. Hey, Blair, why should people put TWIS in the subject line?
Oh, you got to put TWIS, TWIS in the subject line, or your email will get sent to the ISS and we won't get it until February 2025. And then it'll be too late.
Yeah, no, we'll be like, what? This is so old. Oh my gosh.
We look forward to discussing science with you again next week. And if you've learned anything from the show, remember,
it's all in your head. I hope all of you at Burning Man are having fun.
This Week in Science. This Week in Science. This Week in Science. this week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news. That what I say may not represent your...
It's not news. This is the after show. It was news. Now we talked about it. Go to sleep, Blair.
Okay.
I started making all of the show forms for the next few months. So
Great.
and the shows figured out so that we can have a
Yeah,
schedule.
I have to figure out when
forward.
Brian's evening shifts start, so I can
When that
figure out
happens.
what 8 weeks I will miss of the show.
Oh, I don't want you to miss anything.
Yeah. We
In the
can film
next
at a different
couple of weeks-
time, just saying. Throwing
No.
facts out there.
I was thinking of I don't know, there's if you've seen it on Netflix, there's a like the Mind of a Dog documentary. Rob Lowe narrates it, and our great friends Brian Hare and Vanessa are they've written a book called Puppy Kindergarten on their work looking at training puppies. So basically their research is with puppies. We talked with Brian a little bit about it a few years back when he was like on the world's longest interview episode of TWIS. It's like a 3-hour long interview. He was fantastic. But they might come back to talk about puppy intelligence. So maybe,
Fun.
yeah, but maybe we could, I mean, the show just was released and the book just came out. So the timing of it is a little bit off, but maybe we can, I don't know, record their interview separately and use that as like I don't know, because I want you to be involved in the puppy interview very,
would
very much.
Very much.
Yeah.
Okay. All right.
Yeah. I want it's
Cool.
I got a copy of the book and I need to watch. It's on Netflix now, the documentary. So we can watch the documentary at least and then be able to have questions for the interview if we want to.
Mm-hmm. Yeah,
Um,
I'll check it out for sure.
I've been looking at some of the videos and some of the materials they've got, and it's just like, I don't know how they do it because they have to sit, it's dog training, right? So they sit, get the dog to do the thing, and can't touch the animal until after the trial is over. And I could just imagine being like, I'm going to just play with the puppy right now.
Yeah, I mean, that's a lot of working with animals, is wanting to touch the fluffy thing and not being able to touch the fluffy thing. So,
I mean, even with birds,
pretty
I'm like, I
familiar.
want to touch the birds. And like, no,
That
don't
is
touch
a different kind of fluff, but I would still call it fluff.
Some of them are very fluffy and very cute. And I love the birds. Oh my goodness. And the puppies. But yeah, if you want to have another puppy anytime soon, they have lots of great advice, scientifically evidence-based for training your puppy.
That's great. I don't know if I'm ever going to get a puppy again.
You're like, puppy, baby.
It's
done.
my whole life. I wanted a puppy, and I think it was mostly my dad, who might be watching right now, who's always
Dad.
like, no, like a 1-year-old dog.
Get an older dog.
I don't want to potty train. We're gonna get a dog that's already housebroken, already has some training. We're getting a
most
1-year-old
people
dog.
should get an older dog. Most people don't
and I
really
was
want
like,
a puppy.
I want a puppy. And I always had a little bit of a chip on my shoulder about it, and then I got a puppy, and I love my dog so much, and I don't have any regrets. But wow, that was not easy. Well, I also found out the hard way that corgis are really hard to potty train in particular. So
Yay
it's
for
very funny.
corgis and potty training.
It took, I think, over a year to potty train her. And keep in mind, I used to train bears and sea lions and vultures and skinks. And like, I'm
Like,
not
I
a
trained
scout when it comes to animal training. And I could not get her potty trained for over a year. So,
you,
so I
if
get
anyone,
it. Dad, I'm sorry. I get it.
you get it now. And he's just
Yeah.
looking, he's like, shaking his head, going, I told you,
Get it
told
now.
you, Blair.
But that puppy phase is so cute when they're so smooshy.
Yeah.
Big needle teeth.
So adorable. I saw met a cute puppy on the street, 4 months old, cute puppy on the street today. Yeah. I'm like, oh, very adorable little girl, very sweet Australian shepherd mix. So, and she was so just not too crazy. She was like nice. I was like, I'm gonna take your puppy. No.
Maybe when she got home though, a little crazy.
Yeah, probably a little bit. Everyone can be a little bit crazy at home. It's all good. Go. Let it out. Everyone needs a safe space. Let it all out around people who accept you for
let it all out.
animals who wiggle it out, and that is dive into bed.
Yeah. Honk you. Here I go. All right. Well, I'll see you next week.
Go be demure.
I was trying to think of a pun for that, and it's too late, and I'm tired, and I can't.
Demure? You mean like those birds on a rock? Or demures?
Yearns. Them yearns. No, I can't. It's nope. I don't have it. The brain cells have left.
Oh, common the demure antlion? What?
Okay, well, say goodnight, Kiki.
Okay, sorry. I just found there's a demures antlion species. Why do I learn? Well, sorry, I'm gonna say goodnight. Yeah, it's time to go, everybody. I'm gonna go down little rabbit holes. What is that? What's that on the internet? Okay, it's okay. Yes, we're back in school again. Kai's in 8th grade.
Woo! Man, you almost have a high schooler.
Oh no.
1 more year.
He's not a little baby anymore. Yeah.
Slipping through your fingers, as Abba says.
Only have limited time before we all have limited time, but before he heads off to college, if he's going to do that and everything. Ed Thompson, thank you. You're awesome. Thank you, Gord. Thank you, Paul. Thank you, everyone, for joining us for this last episode. Not last, this last one this thing that we're just doing right now. I can't talk anymore. I'm getting up in the morning so I can take my child to school now.
Oh yeah.
Yeah. It's bedtime. It's like getting past bedtime now. Oh my goodness. All right, everybody. Blair's gonna get up at like 5 in the morning because she's wild like that. I'm not. And Fada's gonna go watch Only Murders in the Building and truss up a chicken. So it's exciting. That's exciting stuff going on in the world right now. Say goodnight, Blair.
Good night, Blair. Say goodnight, Kiki.
Good night, Kiki. And good night, everyone. Thank you so much for joining us. We will see you next week, Wednesday, 8 p.m. Pacific time, YouTube, Facebook, Twitch for the live thingy. And if you can't, well, just try to be careful through the next week, okay? Just can't be good. If you can't be good, be careful. And if you can't be careful, Be lucky. Night.